I assume that you, like all my other geometry students, are probably reviewing algebra.
We are, yeah. Well, we're actually doing, our class is still doing geometry. Like we're working on like cosine, reviewing it like cosine, tangent, and
Okay, do you want to send me a picture of anything?
I honestly don't have really anything on it because we just turned in our homework today.
Okay.
Um,
Well,
I could like,
I do a lot of sines and cosines. Let me just do a little quizzing of you.
sure, sure.
You might notice that I have a different screen.
I like that.
Yeah,
Looks awesome.
I upgraded to Windows 10 uh,
Nice. I like that.
over spring break. Well, I wish I liked it as much as everybody else does. I'm not a big fan, but that's partly because I haven't fully uh, adjusted to it yet.
Yeah,
But
right.
um,
It takes a little while to get used to.
well, it's quite a different operating system. It's significantly different than Windows Vista, which is what I was using before.
Yeah. It honestly looks different. Yeah. Like,
Well, it's a
yeah.
different drawing program. It's so different, it's unbelievable.
Mhm. Yeah. Okay.
So tell me what the sine of theta is.
Sine of A.
Sine of theta.
We haven't really learned theta yet.
Theta's
Is
just an
that true?
angle.
Okay.
So
Okay.
I could replace that with an A or an alpha or a letter or anything else. But
Okay.
typically when you're dealing with geometry, you use Greek letters to represent angles.
Okay.
Sometimes it's theta, sometimes it's alpha, sometimes it's beta, uh,
Okay.
but it's a Greek letter. A Greek letter tends to represent angles,
Mhm.
and alphanumeric letters represent vertexes or something. But
Okay.
the sine of theta, you know SOHCAHTOA, right?
Yep. Yeah. SOH, CAH, and then TOA.
Okay, so use the sine.
Mhm. So that one would be 4/5.
What's opposite theta?
Um.
What,
So it'd
what
be
side?
HOA.
What side is opposite that angle?
3.
Right. So that's the opposite side. The
Oh yeah, yeah,
hypotenuse is
yeah.
5. Okay.
Yeah. 3/5. Yeah.
Cosine of theta is what?
Is 4/5.
And tangent of theta is what?
And then tangent would be OA, so it'd be 3/4.
Okay.
Cool.
Now, have you only learned those three, or have you also learned cotangent, secant, and cosecant?
We haven't learned that yet. No.
Okay.
Yeah.
What other kind of trig stuff have you learned, or are you talking about?
Um.
I mean, this is the real basic stuff. Have you talked about trig functions of angles greater than 90 degrees?
Nah. No.
Incidentally,
No.
SOHCAHTOA,
Uh
that
huh.
applies only to right triangles.
Yeah.
Does not apply to triangles like this. In other words,
With yeah.
that's theta, and that's 6,
We've actually.
7, 8.
Mhm.
You don't know what the sine of theta is.
No, we actually just started learning that today. What like without the right angle. Mhm.
So you learned the law of sines today?
Yeah, just briefly. Like we know how to set the equation and such for
Let's
that.
go over it. In other words,
Okay.
what I'm looking for is material that's not going to be new to you in
Mhm.
this review.
Mhm.
Uh, so SOHCAHTOA only applies to right triangles.
Okay.
When you have a triangle like this, you have to deal with it. Well, first of all,
Mhm.
you have to know, you didn't do the law of cosines yet, right?
No.
Okay, let me change it then a little bit,
Okay.
because I would have to use the law of cosines to solve that. Where
Okay.
you use the law of sines is when you have one angle and its
Uh-huh.
opposite side.
Okay.
So if I had this kind of triangle, I can solve it totally
Yeah.
because I have three pieces of information. If you have three pieces of information, you can always solve for all six pieces.
Okay.
Solving for all six pieces means solving for all three angles and all three sides.
Uh-huh.
Well, what the law of sine says is that the sine of A, angle
Over.
A, over side A, and typically if you're using letters for angles, you
Uh-huh.
capital letters for angles, little letters for the side. In other words, this
Okay.
side A.
Okay.
And once you have that relationship, you can solve the whole triangle. The rest of the formula says this. Well, notice we have an angle and its opposite side. So as long as I have that, I can figure out everything else. Well, what do I have?
Okay.
I have the sine of C. So I have this one over here.
Yeah.
So I can say, what?
So you could say, so we have,
Start with the sine of the angle C. What's the angle C?
37. So it'd be sin 37 over 6,
Okay.
because it's the opposite, is equal to...
And let's next solve for A. Oh, excuse me. No, we can't do that because we don't know this angle. We don't know that side.
Yeah.
But we do know this side, B.
Uh-huh.
So the only unknown, in other words, you don't use all three at once. You use just two of them to solve. In other words, the only unknown in that is angle B.
Yeah.
Well, let's solve for it.
Okay.
Do you have your calculator in front of you?
I do. Yeah.
Okay. Just a
So
second.
let's see.
I'm still not used to this eraser.
Yeah, no problem.
Oh, so I've got the sine of B is equal
So we would
to
do
7/6 sine of 37. And it's sine, not sin.
Yeah.
You get a lot of students that want to pronounce it sin because that's what it looks like it is sin, but it's pronounced sine.
Okay.
Okay? Now, this is just a number that you can get out of your calculator. Go ahead and give me what 7/6 times the sine of 37 degrees is.
Okay. Let me go get my other calculator. This was not it's not working right. Hold on.
Okay.
I'll be right back.
All right.
Okay, sorry about that. That one didn't turn on. Okay.
So what we're doing when we solve these kind of triangles is one piece at a time.
Okay.
In other words, I can solve for this angle right now because I know the fundamental relationship. There's the fundamental relationship regarding this triangle.
Yeah.
Every angle and opposite side has to be this ratio.
Okay.
So that's why I can say the sine of B divided by 7. Okay.
Yeah.
And what does this number come out to be? This is not quite automatic. So what's the number over here?
For sin 37.
Times 7/6.
Times 7. Oh, so you do sin... Okay, so you do sin 37.
Sine.
Times 7/6.
Times 7 divided by 6, yeah.
Okay.
Could be a number slightly greater than 1/2.
Divided by 6. Yeah, I got 0.702.
Okay. And that's equal
then you
to
would...
the sine of B. Now, my goal is to find the angle B.
Yeah.
All right, so how do I find B?
You would do sine, or sine, my bad. You do points, it's kind of, it says sin 0.702,
It's
like in the
inverse.
calculator.
It's inverse sine.
Yeah, that's, yeah, with the -1,
Here-
yeah.
Here's the thing. So
Uh-huh.
I would do, yes, the way I'm going to solve this is I'm going to take the inverse sine of 0.702, and that's going to be equal to the angle.
Yeah.
Here's
And
the
then
thing. When you solve for angles, you're always going to be using the inverse trig function.
okay.
When you solve for sides,
hmm
you're always going to be using the trig function. Now,
Okay.
let's talk about that a second, because it's not always that obvious. If I
Okay.
take the sine of 30 degrees, that's the most common one, that's 1/2.
Uh-huh.
That means, if and only if,
hmm
the inverse sine of 1/2 equals 30 degrees.
Uh-huh.
Notice that we use inverse sine to find angles. We use trig functions of angles to find ratios.
Okay.
So if the top statement is true, then the bottom statement is true, and vice versa. And that's an important concept. Just remember, we take trig functions of angles to find ratios, and we take inverse trig functions of ratios to find angles.
Okay.
Okay? So, to get back to, how do I get back to my previous page?
Um, Maybe the back arrow.
Yes, no, that's got to be right. Ooh.
Ooh.
This one right here. There we go.
Ah, there we go.
Magic. Okay. So what is the inverse sine of 0.702?
I got 44.58.
Okay, so I'm going to put that in there.
Okay.
44.
We could just round up to
6. Now, you almost always at this point don't have to use the law of sines, because notice at this point I don't know angle capital A and I don't know side A.
yeah.
But how can
You
I
could
figure angle A?
you could add up 44.6 plus 37, then subtract that from 180.
Okay, that's 81.6, so we're looking at 98.4.
Yep.
That's angle A, even though I haven't drawn it to scale. That's still angle A. And now we can use the law of sines to find side A, side little a. Okay,
Okay.
let me erase some of this stuff.
Okay.
Just because it's in the way, and I don't want to lose my picture here.
Yeah, definitely.
So now tell me how I'm going to solve for that right there. Set up the whole equation.
Okay.
Start with a known angle and a known opposite side, and you can use this angle and this opposite side, or you could use this angle and this opposite side.
Okay. We could do sin 37 is equal, yeah, divided by 6 is equal to sin 44.6 over 7.
Well, there's no unknowns if I do that.
Oh, okay. You want an unknown?
Solve for anything.
Yeah, so we would
These are
do...
all numbers. That is a true statement. That is definitely true, but it doesn't solve for anything.
Yeah.
So what do I need to put on the right side of the equation?
Sin 98.4 over A.
You got it.
Cool.
Now we still have to solve that. What's the next step for solving that? In other words, this is a number, that's a number, and that's a number. So I have only one variable, A.
Yeah.
So I know I'm going to be able to solve it. Anytime you have an algebraic equation with just one variable, you can always solve it.
Yeah.
How do I solve it?
We would do sin 98.4 times 6.
Okay, in other words, you're going to cross multiply.
hmm And then you get 5.93.
Well, we don't need to actually come up with a number.
Oh, okay.
The other side of the equation.
Then the other sign would be just sine 37
Times.
times A.
So now A is going to be
So A would be,
on the right side divided by the sine of 37.
okay.
Right here is your answer. And
Okay.
again, these are all numbers that you can get out of your calculator. And in fact,
Yeah.
you have to get them out of your calculator.
Yeah.
Nobody knows what the sine of 98.4 is.
No.
That's,
No.
you might know what the sine of 30 degrees is, or the sine of 60 degrees, or the sine of 45 degrees, but any of these odd angles you have to do this way. So that's going to give us a number, and now we have all three sides, all three angles.
Cool.
So that's a very typical law of sines problem. Let's talk about these two triangles.
Okay.
Because these two triangles are paramount to trig.
Yeah.
By that, I mean they expect you to know the sine, cosine, and tangent for these common angles, 30, 45, and 60 degrees. And the way we're going to figure them out is, I've been talking about these two triangles for how many years?
Oh, a lot.
At least 3, right?
At least 3. Yeah.
Okay.
Yeah.
Now, what's missing? I need some dimensions on them.
Yeah.
And I call them my unit special triangles. Why are they called unit?
Because that's like the sides of the...
Side opposite the smallest angle is always 1.
Yeah.
That's why I call it unit.
Okay.
And if we know that, then we're going to be able to memorize all of our special trig functions. In other words, that's 1, that's 1. What's the side opposite the 60-degree angle?
The side opposite 60 would be root 2.
Root 3.
Or root 3, yeah.
Hypotenuse is 2. And over here it's root 2.
Root 2, yeah.
Okay? So you want to memorize this picture.
Yeah. Yeah.
Why? Because what's the sine of 30 degrees?
The sine of 30 degrees? 1.
Opposite over hypotenuse.
Opposite, okay. Yeah, yeah.
So what is it?
So it's opposite over hypotenuse. So it would be 1 over 2.
Correct.
Yeah, 1 over 2. Yeah.
What's the cosine of 30 degrees?
Root 3 over 2.
Good. Those are very common numbers. Get used to those. In other words, they want you to kind of memorize what the sine of 30 is, the cosine of 30, the tangent of 30, the sine of 60, the cosine of 60, the tangent of 60, the sine of 45. We're going to answer each of these.
Okay.
They are, maybe not this year, but soon going to want you to have all of these memorized. Well,
yeah, definitely.
That we know is 1/2. That's square root of 3 over 2. What's the tangent of 30?
The tangent of 30 is OA, so it would be 1 over root 3.
What's wrong with that answer?
You can't have a root sign at the
so
denominator.
What do you have to do to that?
Multiply by root 3 on both sides.
So what do you get? Not on both sides, but on top and bottom.
So you would get root 3 over 3.
Right. And that's really the answer you want to give for the tangent of 30 degrees.
Yeah.
How about sine of 60?
Sine of 60 would be, so it's OH. So it would be Uh, 1 over root 3. 1 over root 3.
It's the opposite to 60.
Root 3. Oh, I was looking at the, yeah, so it'd be root 3 over 2.
Okay? Notice that the sine of 60 is the same as the cosine of 30.
Uh-huh.
What's the
Yeah.
cosine of 60?
Sin sine of, oh, the cosine of 30 would be...
No, cosine of 60.
Yeah. Oh, okay. Cosine of 60 would be... so
I do like how nice and crisp.
that is.
So cosine is adjacent over hypotenuse.
Okay.
What's the adjacent side to 60?
The adjacent side to 60 would be 1.
Okay, so it's 1 over 2.
1 over 2, okay.
Notice the cosine of 60 is the same as the sine of 30.
Mm-hmm.
That's actually true of all cofunctions.
Okay.
You can see, well, there's a lot of cofunctions you haven't learned yet. But what's the tangent of 60?
The tangent of 60 would be, so it would be root 3 over 1.
Or just root 3?
Or, yeah, just root 3.
What's the sine of 45?
Sine of 45, which 45 would it?
Second triangle
Yeah. Okay.
Either one.
Oh, okay. Okay.
They're both going to give you the same answer.
Okay. Yeah. So it would be 1 over root 2. So it would just be root 2 over 2.
Good. What's cosine of 45?
Cosine would be 1 over root 2.
And the tangent of 45?
And then the tangent of 45 would be OA, so it would be 1 over, just 1 over 1, or just 1.
Right. Now, everything you see there at some point, probably not this year, but at some point you're going to have to memorize all of these. But rather than memorize those, just memorize these two triangles.
Okay.
In other words, you really don't, no part of me has memorized all of these here.
Uh-huh.
I do not memorize those. What I do is know my unit triangle, and my unit triangle allows me to figure out all of these.
Okay.
Merely if I know SOHCAHTOA, and if I know the dimensions on these two unit triangles, I can figure out all your trig functions for any of these three angles.
Yeah.
And that's a big part of trig. I don't know if they'll get to that part with you guys this year or not.
Yeah.
I doubt that you're going to learn too much more new material, merely because they like to give you some algebra refresh time at the end of geometry, because it's been a whole year since you've had algebra.
Exactly.
A lot of people forget a lot of the algebra they learned in Algebra 1, so they spend the last 2 weeks to a month in geometry reviewing algebra, basically.
Yeah. Yeah.
But trig is also, it's interesting you're reviewing trig.
That is.
Okay, well that's cool. So we're on for 8:30 tomorrow night, right?
Yep, that sounds good.
Talked to your dad briefly. He says you have a baseball game tomorrow night, right?
We were supposed to, but it was canceled.
Be snowed out, huh?
Yeah, it was canceled today because we were supposed to have it up in Evergreen, but because of the snow, they had a foot of snow up there.
So they don't have any way to play your games indoors when they have bad weather, huh?
They don't. We need we need an indoor facility.
Yeah, I guess nobody probably does. Those are not that common.
They're really not. All I know is
indoor baseball fields, yeah.
Yeah, Tampa Bay and then Toronto, I think, are the only baseball fields.
Right. So you're a slave to the weather. I mean, you can practice indoors, probably.
Yeah, we can. Yeah, we just had practice inside today, actually.
Right,
so.
but playing games indoors is a different story. But
Yeah, definitely.
Okay. I'll still talk to you at 8:30 tomorrow night.
That sounds good.
All right.
All right.
Talk to you then.
All right.
Good one.
Sounds good. All right. Bye-bye.